Now often when you have two radicals in a radical equation like this, or you need to not only square it once, but you need to square it twice sometimes, because you know if I square this side, that's a binomial squared, this one will get rid of the radical when I square the first term. When I square the last term, that'll get rid of. But when I take twice the product of these two, it's not going to get rid of my radical. So then I have to again isolate the radical, get everything else on the other side, and then square both sides again. So I've actually squared the equation twice. If I want to square this side, I get the first, remember, squaring both sides, I get y, because root y times root y is just y. Let's square the last term first and do these out of order. Plus y plus 5. And now I just have to take twice the product of these two. Well, that's plus 2 times root. If I take the product of y and y plus 5, I get y squared plus 5y. Now I'm going to leave that like this. That's equal to 25. And now I'm going to take these two y's, add them together, and I get 2y plus 5. And I'm going to bring them over here. So I have 2, so the only thing I'm going to leave over here is this. 2 times y squared plus 5y is equal to, if I take the 5 over here, I have 20 plus, or minus, sorry, minus the 2 y's that I'm bringing over also. Now I'm going to divide both sides by 2. When I divide this side by 2, I just get the square root of y squared plus 5y is equal to, now when I divide this by 2, here's an example of when you can cancel out again into these two terms. Both of them are divisible by 2, so I can get 10 minus y on this side. Now when I square both sides, I get y squared plus 5y is equal to 100 minus 20y plus y squared. Remember, twice the product of the two terms when you're squaring a binomial. Now I have a y squared on both sides of the equation, so that just cancels out. I can subtract that out. And I have 20y, or I can have 100 minus 25y is equal to 0. And now I can factor this. It's the difference. I can take out a 25. It's not the difference of two perfect squares because I don't have a y squared, do I? 25 times 4 minus y, and here we get y is equal to 4. Now I squared this twice, so I do want to check this answer. So I go back to my original equation up here. Let me erase some of this stuff over here so I can go back to my original equation. Let's put that 4 back in here. The square root of 4 plus the square root of 4 plus 5 is that and equal to 5. Well, this is 2, and this is square root of 9, which is 3, and yes, that is equal to 5. 5 equals 5. Well, sometimes you have to look at these equations and you have to figure out which way is it going to be easiest for me to square both sides, because obviously I have 2. I'm going to have to square this a couple times. So what I'm going to do first is, I think this problem particularly would be easier if I added the square root of 2b plus 5 to both sides. It just makes it a little bit easier. So I end up with just this over here, the square root of 3b minus 2 equals 1 plus the square root of 2b plus 5. Now that I have this over here on this side, I actually find it's easier to square both sides this way, because squaring this side I just get the 3b minus 2. Over here the nice thing is it's got that 1, so 1 squared is 1, plus this squared is 2b plus 5, and when I multiply these and double them I just get plus 2 times root 2b plus 5. Okay, now I'm going to isolate this thing all by itself by getting the rest of this stuff on the other side. So I get b over here, because 3b minus 2b, and I have a negative 2, and I'm going to bring over 6, so I get negative 8 equals 2 times the square root of 2b plus 5. Now, at this point, normally we divide both sides by 2, and that's great. But when I divide 1 by 2 over here, I'm going to get a fraction, and I really don't want to do that because I can square this side without getting rid of the coefficient, the 2 in front of the radical. So if I square this side, I just have to remember to square the 2 also. So I square this side. So now I'm going to get b squared minus 16b plus 64 over here equals square the 2, and I get 4 times the square of this is 2b plus 5. Now I have 8b plus 20 over here is equal to b squared minus 16b plus 64. And now I'm going to get everything on the other side. So I have b squared minus 24b plus 44 equals 0. And now this factors into b, and this is 22 times 2, and the 20, they're both negative to make this positive. So now I have my two answers. B is equal to 2 or 22. So I have to figure out which one of these back into the original equation works. And I'm going to leave that up to you to go ahead and do.